What is energy? Now, everything around us is energy. From the cars that we drive, to the electronics that we use, even to the foods that we eat. Everything, literally everything is energy. And in physics, energy is defined as this. It's the capacity for doing work. But that really doesn't mean much to the layman, so it requires a definition to understand what work means. And to do this, we're going to cover some of the different forms of energy. Now, there are many different forms, as you can see here. For example, thermal energy, mechanical energy, chemical energy, elastic energy. But really, they can be broken down into one of two types of energy. One is kinetic, and the other is potential. For example, your car has mechanical energy. It's an object in motion. When it is moving, how does it get that energy? It gets it from the gas in your car, which is chemical energy. It's potential. It's been stored until it's released as energy, which allows your car to move. And we're going to give a couple examples of how energy can be used to do work. And in these examples, they're purposely using particles that you see here. In this example, the conduction of heat, it's air molecules that are vibrating and heating up, causing the motion of those particles. Now, the thermal energy can be used to do work, for example, to cook food. And the vibration of these molecules is an example of kinetic energy. Now, nuclear energy is potential energy. It's stored energy in the atoms in the nucleus of an atom, and it can be used to do work, for example, if it's split and that energy is released. And that work could be used to spin a turbine, which generates electricity. And that's what happens at some nuclear power plants that generate electricity for your home. But a key rule in physics is that energy is always conserved. You can see here the example of the roller coaster car, and energy is always conserved. It's always 100 there, but yet potential and kinetic energy changes. And this is a clue. It's a huge clue, really, that there must be a common source of all energy, one that can change forms for this to happen. So we're going to ask this question again. What is energy? And we'll use an analogy here. It's much easier to have analogies. There's things that we can see when we try to compare the world that we can't see. So imagine a pool of water, right? And this pool is flat and motionless. There's no energy in the pool. Next, imagine an earthquake shakes that pool. Now, water is moving in all directions in the form of waves, right? The pool has energy, and it can do work. It can move objects. Now let's imagine a universe that has a medium. Right? A medium is the same thing as the water wave in the pool. But in the case of the universe, it's referred to as an ether. And if an ether exists, it could be described the same way as the pool. Energy is the motion of the ether, which travels as waves. Now the nice thing about waves, right, they have 4 simple properties, and energy can be calculated based on those 4 properties for any given volume. Another nice thing about waves, waves have 2 directions of vibration, and that's relative to the wave motion. One is called longitudinal, which the vibration is in the same direction as the wave. And the second is transverse. The particles in this case are going up and down in right angles in the direction of the wave motion. And you see longitudinal and transverse here have associated some forms of energy not covered here, but you're welcome to go to the website to find more information. Now another nice property about waves, 2 types of motion. One is traveling, this is what everyone would expect from a wave that is in motion. But there's also something called a standing wave. And a standing wave is a result of a wave that's being reflected. Think of it as an in wave bounces off something, it's reflected as an out wave, and the combination of those waves, if they're at the same frequency, produces what's called a standing wave. It's a wave that is stationary. And this accounts for the basic forms of kinetic and potential energy. Particles are essentially stored energy, standing waves, and traveling waves cause their motion. More information at the website, which you can see the URL on this page. Now, waves can change form and motion, but its energy will always be conserved. Right? Then the universe can be modeled as waves of energy flowing through the ether. This becomes the single source of all energy.